Hello everyone, I'm Xiaogang. Okay, now let's start writing the two most complex files, which are these two. These two brothers are really complex. And why are they designed so complexly? It's also quite good. Designing it this way makes it convenient for everyone to look at the engine's completeness, or when looking at other plugins, it helps everyone understand why they sometimes design things that way. Actually, this plugin can still be further improved by adding some mass email sending, or some other functions like that, but we don't need to, because we just want to make a simpler verification code. And then these two things. How do we write them? Let's write this thread first. Now, this thread seems quite complex too. So let's write this ExecAction first. Let's write the basic files for it first. And then when we write this part, it needs to be a bit more special. First, let's have it include the runnable. And this runnable and this basic data types. Okay, why can we directly include runnable here? Because actually we have wrapped a layer. That is, it's equivalent to the layer above our runnable. The layer above as the active action, and then below the runnable is the TCP thread, because we plan to use this hierarchical structure, so we just need to include it here. And that's it. Okay, here we will create a simple forward declaration of socket. Then we need to define this one-step action. Then this one-step action, we consider it a get for it. We don't need to export macros, okay? You often don't write export macros like this. This thing has one advantage. It can reduce the code dependency on your module class. It has relatively good encapsulation, and it reduces the exported files, under size, etc. But it has a downside. Once someone asks you to make changes, because you might not be able to, there might be bugs, or it might not fully meet their needs. And if you haven't provided the source code, it becomes quite troublesome. If you haven't provided the exported red, you can just make others very annoyed. So this is a small detail. Sometimes whether or not to add the export macro depends on how you think about it. Our Pleco doesn't have any issues, because our plugin basically provides the source code. You can modify it however you want. Take it and modify it however you like. That's all fine. But before modifying it, you must understand why we wrote it this way. That is, our constructor and destructor. And then here, why we let it inherit this pointer. Because we want to guess it's a weak reference object. Actually, we hope this thing of ours. It is during construction and destruction, we need to complete the corresponding release of existing resources, and we don't want it to be copied back and forth when in use. So we use smart pointers here, because we hope to use it in the standalone engine. So we cannot let it inherit our usual. Cannot let it inherit from Baji to write something like ACCP texten, because that is for the engine to use. To be precise, it cannot inherit from what we wrote for you in the previous two lessons. That UBL that ExecAction, it is not that it cannot inherit from Oblu, because we found that here it does inherit from Oblusk. This is fine, because this is something related to our lowest level core module. Okay, good. So with that in play, we have its construction and destruction. Let's create its implementation. Good. This is where it gets more complicated. We can only give it to you all at once, because if we explain it in bits and pieces, it's really hard to explain clearly. So first of all, this is the constructor and destructor we wrote earlier. We have many resources being allocated and released here, and this is where we actually create such an action. So when we create this action, we definitely need some info. There is such information. This information is passed from our blueprint. This is the delegate that our blueprint needs to call back. This point should be fine. Let's create it here. Okay, I turned off war. It's a spell check for that, because I just turned it off here. It's quite annoying. You can just click into it here. It has an auto fix. Just turn it off. Then we actually have many other methods here. We can definitely directly stop her. This accept action, because we might get stuck at some stage. So we also need a method like this. You can take notes on this, because I'm already very clear about it. So I just wrote it for him directly. Here we can get the ID of our current action. Then we can get the current communication status. Okay, as for this status, it is at the very top. It is this status. Let's go back again. So here, we definitely have an active. Here we are writing it by imitating the engine. So we also have this active but you need to know whether it is the same thing as the engine's active. And similarly, we are here. We need to process this information. That is, we need to use this information on our end. Therefore, we need to store it. This related email info and this deleg, because we have a one-to-one correspondence. So we need to store it here. Then we will create this method here. But let's write these methods first. Obviously, for the return value here, we can actually just return this ID. As for this ID, it actually needs to be initialized during construction. Because this ID is unique, that is, we won't let you set it, because we will let it go through the constructor initialization for everything. Then, as for the state, we just need to change the state back. Okay. Then, as for this activity, this writing method is actually the same as our previous writing method. Here, we get the current pointer, and then in a linear fashion, we treat it as a shared pointer, and then we let it execute in one step. Okay. Then here is where it actually activates. This method is not yet available. Let's go create it. This must be protected. Our internal logic is written right here. Okay. Next, we'll add a few more methods. This part might be a bit fast, but there's no way around it. Right here, write these three methods. These three methods are obviously bound to our thread, because when needed, we let it execute the relevant work accordingly. So it's just a TCP callback. It calls back into these methods. Right. Okay, no problem. Okay, these methods exist. What's next? Actually, we still need to prepare a few methods. These methods. One is to get the IP of our server. Of course, this IP method is actually left for testing purposes. So it's a reserved method on our end. This IP will change. That is, if you want to look up the IP of a domain name, this IP may change. Sometimes, when you do testing, you temporarily hardcode this IP. That's fine. Because our IP, the specific IP address, needs to be obtained through some methods before you can get it. Then we have a method here, which is to send a message. So it's also written here. Okay, good. Basically, it's fine up to this point. Then here, we still need to write a few methods. We have one here. Finally, when we make the call, are we going to execute this agent? So we have this method. Okay, as for this agent, it is actually quite simple. We just need to execute it in one step. The type of this agent is passed in by him. Okay, so this agent, then here, there are a few more methods that we need to create this runnable and close this runnable. We create this runnable here. Close this runnable, okay? We don't have it now, so we'll just put it here. And actually, here we need to let our subsystem know about it. The meaning of this method is to let the subsystem know about it. So here, we'll leave it blank for now. And this stat close mainly handles some information when we close, because sometimes we close normally. Sometimes we close abnormally. We need to process this information. Just do a simple processing like this. Basically, we have created the methods needed by this class. You might be a bit confused, but actually we've already explained a lot earlier. WebSocket talks about HTTP. These methods are actually more or less the same. And now let's start to create this aspect action. So here, we follow the traditional workflow. What is this workflow? First, we create such an object. And at the same time, we get a smart pointer pointing to this object. And this is our actual instance, because this method is static. After creation, we change its current state to this init state. Right. Here we need to call this media, because we just created it. We haven't initialized it yet, so let's copy the corresponding email information and delegate as well. After finishing, we let it call the activity. Okay, then let it call the activity, and at the same time, we give this object to it. This can only be returned to it. This is fine, no problem. But here, you can write it however you like. Because this thing, we don't plan to give it to users. So it's like this. Then next, we go to the MVTVT. After MVTVT, the work to be done. It's actually very simple. We just need to create a thread. we just need to call the method we already wrote, create runnable. That's it. As for this creation method, now that we've entered, we need to start doing some logs of dang when recorded. First, we need to provide a log. That is to say, we are now going to do this kind of work. So having provided the log, we need to include the header file of the log. Let's put this here, put it here. This header file, okay, with this header file, we can then output the log here. Okay, with this log, we will start the next step of work. First of all, we need to create our runnable. Next, we bind these methods of Shengyin to the runnable so that the runnable can call back. Then we split our state like this. So how do we write this part? First of all, we definitely need to write a runnable, right? Then at this point, we jump to our runnable. Let's write the runnable. Then go to its header file. The runnable is actually a classic way of writing this. First, let's include the thread-related stuff for everyone. Now let's write this. Okay, first, let's write a cloud socket. We'll use it later. And this runnable, we need it to inherit from FRunnable. We need to use a separate thread task to do it. Don't miss this semicolon. Missing it will cause compilation to fail. Then, so for convenience in this chapter, we can provide a constructor here. This constructor takes the server's IP and the server's port, and this is its destructor, right? And at the same time, it has 4 methods. These 4 methods are built in, right? Now that we have these things, we'll add the rest later. We need to save the parameters passed in. So there are these 2 variables to save it. Then here we have this running thing to facilitate lifecycle management. So we create it here. Let's take a look. Okay. We can skip writing the code here for now. For now, we just have this runnable ready. We'll refine the runnable in the next lesson. And let's go back to our seek. Go back to this place. Okay, so here we need to create runnable. So we know that in the constructor, we just wrote this runnable. It is actually this. It is such a constructor. We'd better change this name. Change it. Okay, we need to add symbol to this name. This makes it easier to distinguish. After changing it here, this is the most error-prone part, because sometimes you might not change it properly. Now to change it properly, where is it not changed properly? It might be this low. This way it's okay. Okay, let's come back to our acceptation here. Change the name here. And this object is a smart pointer. We need to let it hold. That is, we come to our header file here. The header file here, then at the very bottom here, we let it hold this runnable task. Put it here, okay. Good. Then because there is a runnable, there must be a run thread pointer. There must be this pointer. So we take this run thread and also declare 8 here. Then here, after declaring 8, we use make share to create a runnable. Thus, for this task, we definitely need to pass the server's IP and port. The IP here will be assumed as this IP for now. We will change it later. The port is M32-005's port. This is what the server told us. Then here, so on our end, we also need to bind some delegates, but we haven't written them yet. We'll just ignore it for now. We'll leave it empty for now. Then, after we finish creating it, we can treat our current system as being in a connected state, right? But whether the connection was successful, we still don't actually know. It's just a connect state. This connect is not very reliable. Then next, we take this runnable and throw it into the thread, right? Okay, as for this county, we should have a county name. We can say, wait, this runnable, let me check. Did we give it a ready-made name here? Obviously, we are missing a ready-made name. So let's add the ready-made name, because we still need to add more things. I'll try to explain to everyone why we need to add this and what it will look like after adding it. Okay, this ready-made name, we can just throw the card outside. Just put the card outside. I just can't be bothered to get this ready-made name. Okay, let's go back to our exempt action. Alright, at this point, this step is successful. After this step is successfully completed, then we created it. You definitely need to close it, right? So how do you close it? That is, when this thing is available, we can directly call the existing management, and then for this thing, to ensure there are no leaks, we just close the existing ones. But when your thread is acquiring in the acquire function, we must ensure that this thread is closed. You can see it is already closed. Yes, if it has already been closed, whether this thread exists, if this thread object if this thread object still exists, then we need to wait for this thread to finish executing. After this thread finishes executing, we then delete it and then set it to a null pointer. That should do it. Okay, actually here, if it's already turned off, you can reset it. Yes, because you only need to turn it off once. But here you can reset it. Okay, there's no problem here. This way we can ensure the entire county is okay. But in practice, how do we stop this obligation action? Actually, for this part, we only need to close the county. But if we stop it, we don't need to let it go to the main model, because the main model is when this object is actually recycled. Then we just let it perform the main shot. Okay, basically, the content about the generated assets ends here for now. Then here, its creation call has not been called yet, and these methods have not been executed yet. Also, this course method has not been written yet.